Okay students, now we are going to do this activity to observe the static frictional force, limiting frictional force and the dynamic frictional force. As you can see, we will need only two objects to do this activity, a wooden block to which a hook is already attached so that it's easy for us to connect the Newton balance to the block. And as you can see here, there is the Newton balance which has the readings in Newton. If it is 1 Newton, that is equivalent to 100 grams. So we can apply the force by pulling the Newton spring balance. So for the start of the activity, I will apply a small force on this wooden block by pulling the Newton balance. Then you can see the observation, the change that is going to take place. Here as you can see, initially the reading shows 0 Newton and when I increase it, it comes to 0.5 Newtons, then 1 Newton up to 1.5 Newton. When I apply the force, the wooden block did not move. So from this observation, you can understand that when I apply an external force, that force is being balanced by the force that is exerted by this surface. That is what we call as the frictional force. And since the object is not moving, it is the static frictional force. And when I keep on increasing the applied force, the static frictional force also increases. But that has a limit. Once it reaches the maximum limit, we call it the limiting frictional force. And thereafter, we'll see what happens if I apply more force. Now again, I'll start from 0 Newtons. You can see it's coming to 100, then up to 150 grams, that means 1.5 Newton. And further when I increase it to 2 Newtons and more than 2 Newtons, when it is almost 2.5 Newtons, you can see the block is moving. So that means students, up to 2.5 Newton, when we apply the external force, that is being balanced by the static frictional force. So there, the 2.5 Newton becomes the maximum value for this force when the object is not moving. That is the limiting frictional force. Thereafter, the block started to move. The surface exerts a force on the block. That is why the block did not skid off the table, but it moved continuously. So that force, the force exerted by the surface of the table on a moving object is known as the dynamic frictional force. So from this activity, you have observed clearly until 2.5 Newtons, there was no movement on the block. That means there was a static frictional force and it reached the maximum value 2.5 Newtons. That is the limiting frictional force. And finally, when we applied force greater than 2.5 Newtons, the cube was moving and on the wooden block, there was a friction being exerted. That is the dynamic frictional force. So with this, you have clearly observed the three types of frictional forces. Okay students, now let us do this activity to observe the effect of nature of surface on limiting frictional force. So as you can see students, we have two sandpapers, one with less roughness and the other one with more roughness. You can even use more than two papers, but here for the demonstration, I'll be using only two types of sandpapers. We have done this activity before. We will be using this wooden block as the object and the Newton balance. So I will place the wooden block with the Newton balance attached to it, and when I pull the block, you can observe the Newton balance reading, and that will be the force that is needed to move this wooden block. So here you can see whether it changes with the nature of the surface. That is the roughness of the two sandpapers. So now we are doing it with less roughness. You can see when I apply a force, when it comes to 2 Newton, still no movement, but when it goes above 2.5, almost like 2.8 Newton, the block moves. So the force needed to move this object from rest on this less rough surface is about 2.8 Newtons. Now, the same activity we will repeat with the second type of sandpaper, the sandpaper with a little more roughness. So, I will place the same wooden block here, and again I will try to pull the wooden block. So, you can observe the reading, that is the force needed to move the object on this surface. So here, as you can see, when I keep on increasing the force, it's not moving, and above almost 3 Newtons, a little more than 3 Newtons, the block is moving. So on this surface, you saw that with about 2.8 Newtons, the block moved, and here a little more rough surface, we needed to apply more than 3 Newtons. So that means when the roughness increases, the frictional force increases. Therefore, the force that we need to apply also increased. So students, by observing this activity, you can understand the effect of nature of surface on limiting frictional force. When the roughness increased, the frictional force increased. Okay students, now let us do the activity to observe whether the surface area of an object has an effect on the limiting frictional force exerted by the surface of the table. So for that, I will need a wooden block like this. This block has different surfaces. As you can see, this is a surface which has a high surface area. You can look at this surface, it's a larger surface area. At the same time, we can use this other surface which has a smaller surface area. But it is the same block, the small surface area and the large surface area. I'll be using both the surface areas. So here as you can see, this side and this side both have the same surface area and the same texture. So there is no other effect on the frictional force. So first I will place the larger surface area on the table, and to that I will connect the Newton balance to the hook. And then when I apply the force, you can see and observe the force at which the block starts to move. So you can see here when we apply the force gradually, I have already explained to you in the previous activities as well. The Newton balance has Newton reading, and if it is 1 Newton, that is equivalent to 100 grams of force. So either way, you can observe the force exerted on the block. Now observe what happens when I apply a force. You can see the force increases. When it reaches above 2.5, you can see wooden block is moving. So there we can see that the frictional force, that is the limiting frictional force exerted by the surface when it is the large surface area is 2.5. So now I am going to change the surface area of the block. As you can see, this is a smaller surface area, and this surface and the surface that is in contact with the table are the same. So that has a smaller surface area compared to the previous instance, that is this surface. So now if we try and apply the force, you can observe when the block starts to move. So here, as you can see, when it is close to 250 or 2.5 Newton, the block moves. So as you know, students, although we expect an exact value of force for both the surface areas, there can be slight differences in the surface of the wooden block and the surface of the table. Therefore, we get approximate values. But in both instances, you saw that the force that was needed to move the block was 2.5 Newton or very much closer to 2.5 Newton. So that means the surface area, the area value, the magnitude of the surface area does not affect the limiting frictional force. It is the same as long as the object is the same and the surface that exerts the frictional force is the same. So you have observed this activity and now you know that there is no effect of surface area on the limiting frictional force. Okay students, now let us do this activity. Here we are going to observe the effect of perpendicular reaction on the limiting frictional force. So when we say perpendicular reaction, when there is an object at rest on a surface, the weight of the object acts downwards and the perpendicular reaction is against that. So then the object is at rest under balanced forces. So when we increase the number of blocks, we are increasing the weight of the blocks, that is the total weight increases and therefore the perpendicular reaction will increase. So for this activity, I'll be using 3 similar wooden blocks with equal masses so that we can gradually change the perpendicular reaction. And to apply and determine the force applied, we use the Newton balance. And you are already familiar with the Newton balance. It has the gram reading as well as the Newton reading. So for this block, I connect the Newton balance and apply a force and note down the force that is needed to move this wooden block. That will give you the limiting frictional force. So as you can see, when I increase the force little by little, you start from 0 and the force increases. When it reaches 1 Newton, the block starts to move. And with 1 Newton, the block can move easily. So that means when we use one block, the limiting frictional force is less than 1 Newton and therefore when we apply 1 Newton force, the block starts to move. And when the block is moving, there is a dynamic frictional force acting on it. But here we are going to see how the perpendicular reaction affects the limiting frictional force. So for that, I place the second wooden block on the first block. So the weight of the cube increases. Therefore, the perpendicular reaction increases. Now, when we connect the Newton balance and apply a force, observe the force needed to move the objects. So here you can see at 1.5 the blocks have not moved. But when I apply a force of almost 2 Newton, the block is moving. That is, the two blocks combined together move with a force of 2 Newton. Earlier it was 1 Newton, now it is 2 Newtons. And for the next activity, the next part of the activity, we use 3 wooden blocks. So here we have increased the perpendicular reaction further. And now when I try to apply the force, you can observe I increase the force to 1.5, 2, no movement, 2.5. When it comes to almost closer to above 2.5 and between 3 Newtons, the blocks are moving. You can see slightly there is a difference between the three blocks. Therefore, the perpendicular reactions of the three blocks are not exactly equal. Therefore, you can observe an increase in the force needed to move the blocks, but it does not increase with the same magnitude. So, from the activity you have observed, when we increase the perpendicular reaction, the force needed to move the blocks increases. That means the limiting frictional force exerted by the surface increased. So, therefore, perpendicular reaction is directly proportional to the limiting frictional force exerted by the surface.